Solving quadratics using the square root. In this video, you're going to learn how to solve quadratics, how to find the solutions of different types of quadratics using the square root method. Now, the square root method is used only in unique situations. You have to look out for these situations, and they are when we have two terms. So, in other words, your typical quadratic looks like this: ax squared plus bx plus c. So we have our x squared term, we have the bx term, and we have the constant term, our c. Well, to be able to use the square root method, the equation must only contain two types of terms: the x squared term and the constant term. So in other words, this middle term, this x term, cannot exist. Okay, it's not there. That's when we get to use the square root method. Now, the square root method is really nice and it's really easy. Again, if and only if we have these two specific terms involved only. And of course, that's what we want to make this as easy as possible. So the reason it works only when we have these two specific terms is because there's a single x involved, versus the other way, where there's two x's involved. We can't use it this way. We have to factor in this case. Okay, going back to this method. So we have these two terms, and there's a single x, which is perfect because what we can do is isolate everything that is around the x to get it by itself. So what we do is we move the c over, and we have this here. Next thing we got to do is, okay, how can you get rid of that power of 2? Well, the inverse of a power of 2 is to take the square root. So we take the square root on both sides, and anytime you take the square root of a number, you're going to have the positive or the negative version of that particular number. So our two solutions would be x is equal to the positive side of that value, and x is equal to the negative part of that value. So in other words, let's say I had the square root of 9. Well, if you take the square root of 9, you would get plus or minus 3. If you had the square root of 16, then you would have plus or minus 4. Okay. So let's look at some examples. Here we have a binomial. Do we have the two terms that we need, the x squared and the constant? Yes, we do. So what we need to do is get this x isolated, move everything away from the x. We start with 81. Move the 81 over by adding it to the other side. And we have x squared is equal to 81. And again, get rid of this exponent of 2, the power of 2. How do you get rid of the power of 2? How do you cancel it out? Well, by using the inverse, the opposite, which is the square root. So the squared and the square root cancel each other out. X is no more surrounded by a 2 or by the square root, and so we get the square root of 81. Well, the square root of 81 is 9, so we have x is equal to plus or minus 9. What that means is x is positive 9, but x is also negative 9. And these are the two solutions. As you can see, it looks fairly easy, but of course, these problems tend to get a little more challenging as we go. So, 2x squared minus 242 is equal to 0. We have the x squared term and we have the constant term. All I see is a single x right there. So what we're trying to do is we're trying to isolate it by moving everything away from it by performing the inverse operations. So we start off by moving 242 over by adding. And so we have 2x squared is equal to 242. Next up, we got to get rid of this 2. 2 is multiplying the x, so we got to divide it. And so we have x squared is equal to 121. Next is, okay, how do we get rid of that power of 2? Take the square root. What you do to one side, do it to the other. This power of 2 cancels with the square root of 2 and or the square root. So we get the square root of 121. Now 121 should come to your mind as a perfect square because 11 times 11 give us 121. The square root of 11 and 11 is just 11, but it's plus or minus. So therefore we have that the two solutions are positive 11 and negative 11. Next problem. We have our x squared term and our constant term. We have a single x. Perfect. Everything is perfect. We move the 16 over by adding it. And we have 49x squared is equal to 16. We divide by 49. 16 divided by 49 do not reduce, so we leave it as a fraction. Then we take the square root, because that's how we're going to get rid of this power of 2. Take the square root on both sides. So, now we have x is equal to the square root of 16, and remember, we're allowed to write it like this, divided by the square root of 49. Of course, our final answer cannot remain like that, but if you remember, the square root of 16 is 4, and the square root of 49 is 7. So we have plus or minus 4 over 7. X is positive 4 over 7. X is also negative 4 over 7. And these are the two solutions. So, not bad. Next up we have this here, this quadratic equation. Now just by looking at it, you're probably thinking, okay, there's 3 terms. How is this going to work? You said only the x squared term and the constant term, but what is this number doing here? So you got to stop and think. This 6 with this 186, they're both constant terms. They're both like terms. So what we're going to do is we're going to combine them. Now, what's unique about solving square roots is the equations, quadratic equations with the square root method is that they do not have to equal to 0. Because what we're trying to do is we're trying to move everything away from x. We're trying to isolate it. So that's what we're going to do. We're going to move the 6 over by subtracting. Then we're going to divide by 5. But that's not just any 5. That is a negative 5. So we divide both sides by negative 5, and we end up with a negative 36. So x squared is equal to negative 36. We take the square root. We take the square root. So x is equal to the square root of negative 36. For the purpose of it being algebra 1, this cannot be our answer. Our radicand can never be negative. Therefore, our answer is no real solutions. We cannot end up with a negative inside the square root. When that happens, that's it. Stop right there. Your answer is no real solutions. Next one. 3x squared is equal to 225. Remember, this type of problem does not have to be equal to 0. There is a single x. Move everything away from it. The 225 is already away from the x squared. all we got to do is, okay, now divide by 3. Then we take the square root. And you got to think, okay, square root of 75. Is 75 even a perfect square? The answer is no. So we end up with a positive or negative square root of 75. So we have x is equal to the positive square root of 75 and x is equal to the negative square root of 75. Unless instructed to round to the nearest tenth, hundredth, type it into your calculator and actually round the answer, which if we round to the nearest tenth, we would get approximately 8.7, positive 8.7, and we would get approximately negative 8.7. Again, if you're told to round. If you're not told to round, then this would be our final answer. Positive or negative square root of 75. Okay. Next example. In this next example, we have something very unique where we see a power of 2, but we see parentheses and then the power of 2. So it's not like the other ones where you're going to think, oh, just move the 3 first. Well, we can't get into the parentheses until we get rid of that power of 2. So we got to start off with getting rid of the power of 2. How do you get rid of the power of 2? You take the square root. What you do to one side, you do to the other. So power of 2 cancels out with the square root. So finally we have x plus 3, no more parentheses, no more power of 2, no more square root. So this is equal to plus or minus. Square root of 4 is a perfect square, and it gives you a 2. Okay. We are still trying to solve for x, trying to get this x isolated. So we got to move the 3. So here's what's going to happen. We're going to subtract the 3, and we're going to have x is 3, negative 3, when we move it over, plus or minus 2. So what this means is we're going to have x is negative 3 plus 2 and negative 3 minus 2. In other words, negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. So these would be our two solutions. Okay. So again, the problem looks a lot different than the other ones, but we still applied the square root to find our solutions. Let's try another one. So several things going on here. We have our x trapped inside parentheses together with the minus 8. This parentheses is surrounded by a power of 2, but then we also have a 2 in front of the parentheses that is multiplying. So how in the world are we going to get this x isolated? Okay, well, I'm going to do my balloons, starting with the x, because that's the one we're trying to get to. Trapped inside with the x, we have the 8. What's trapping those 2 inside the parentheses is the power of 2. So therefore, I have my 4 circles. Think of these as balloons, one balloon inside the other one. If I pop the first balloon, that means I need to get rid of the 2. To get rid of that 2, we divide. So divide this by 2, divide this by 2, that cancels. Then we have parentheses, x minus 8 raised to the power of 2, and that gives us 256. So again, to try and get x isolated by itself, we got to get rid of this 2, the power of 2. To get rid of the power of 2, you take the square root. What you do to one side, you have to do it to the other. So then we have x minus 8, no need for parentheses, plus or minus the square root of 256. The square root of 256 is 16, because it's a perfect square. Next, we got to move that 8 To move the 8 over, right here, we need to add it. So we have that x is equal to 8 plus 16 or minus. What it means is that x will be equal to 8 plus 16 and x will be equal to 8 minus 16. The result that we get from these two will be our solution. So our first solution is x is equal to 24, and our second solution is x is equal to negative 8. Now we have found our solutions to all these quadratics using the square root method. Again, remember, square root method is very unique in the cases in which you can use it. It doesn't always work. Keep that in mind.